So this is our presentation for face mask detection software that we created. Obviously by me, Jesse Beach, Gregory Boardman, and Tegan Stoddart. Introduction. So basically what we did was an image classification problem, so whether someone was wearing a mask or not a mask. The motivation was obviously the COVID-19 pandemic, where masks were very vital to the stopping the spread of the virus during the pandemic. We kind of decided we wanted to do something with masks, and the image classification problem seemed to be one of the more doable ones and one of the more real-world applicable ones, since if an establishment or someplace wanted to check how many people were coming in with masks, or if they wanted to check if someone wasn't wearing a mask, if they didn't want to let them in, then mask detector would be very useful in that sort of establishment. There's actually already examples of that across the world. There's a company in South Korea called SUPREMA, and they actually they're a company that does a lot of like face detection software, and they actually implemented a face mask detector to make sure that people going into businesses or establishments were wearing masks. Otherwise, they were denied access to the establishment. So what did we mainly do with the what was our contribution to the project? Well, one thing we found, there wasn't actually a readily available data set of like people wearing masks and people not wearing masks. So we actually had to go in and collect our own data set, which was mainly done using Google Images, but we were also able to take some pictures of ourselves with and without masks as well to feed into the model. Um, we also used two AI models during it and interfaced them together. So one was a pre-trained face detection model done using OpenCV, and then there was a mask detection model that we trained ourselves, which we'll go more in depth to in a minute. And we also, Greg specifically, he coded a way to, if we wanted to add more data to the project, if there was more time available and more people to try it with, there was a quick way that we could gather many images if we wanted to, as well, and we'll go more in depth on that in a minute. So, main things we use TensorFlow and Keras to create this project. We used a neural network, um, specifically a convolution 2D neural network. And then we also used an image data generator to collect the images from directories, which we had set up like in the bottom left corner, where we had to set up the directory such as this, so the image data generator class could quickly sort through them and like say whether they are a mask or not a mask. And it did that automatically and then fed that into the neural network so it could classify it very quickly and train it pretty reliably. This was a neural network that was created by Vibe Have Sharma, and we fed our own data set through it to create it. We also tried a few different ones, but this was the most accurate with these like layers. And then I'll hand it off to Greg so he can talk about what he did with OpenCV.
I used OpenCV to use that pre-trained model that we didn't make to sort through over 700 images of faces we collected in our dataset to then crop them and put them into the database. So one of the problems we had was that the crop size was sometimes we thought the crop size was too small, so we just edited the method to increase the size a bit when we wanted it to. It accesses the webcam and creates an overlay of rectangles and feeds it into our in that it crops the image of our input and where the face is detected, and then feeds that cropped up face to our model. And if its assurance is less than 50%, then it'll create a green rectangle that says say no mask. And we ended up with one thing it was not particularly good at was using masks like the one shown here. But I found out that, what do you know? It's very good at the traditional blue masks that doctors wear. When it's using non-traditional masks, it is a bit finicky with lighting. But it is absolutely phenomenal at blue masks. It just loves those. It can go as low as 0.05% assurance, which means that there's definitely no mask. There definitely is a mask. And it goes to up to 98% accuracy if there is no mask. Assurance, not accuracy. But if we had more time, well, if there was no COVID, maybe this would be a lot easier to collect non-traditional mask data. Jesse can show the video of it working.
So there, I believe it just worked there, and then hopefully that recorded. So for validation and testing, we actually tried it with basically 4 different data sets. So the first data set was obviously all the unedited images we collected, but those had backgrounds in them and extra information on there that just was not necessary for detecting a mask. So the second data set was what Greg talked about. He used OpenCV to just crop the faces out, and these were colored images, but they just had the faces and like the mask. So, and then we actually did use that and then turn that to Grayscale as well to test it with that. And we also did one where OpenCV has a method that like takes the just outlines all the edges and like just does like a black and white image of just the edges. Though we found that to be rough, very inaccurate. So then we tried it with 2 different models. The first model would we mainly just kind of used for testing and like understanding what was going on. It was a simple neural network. It just had about 3 dense layers, and this model was not that accurate. We got it to a max of about 75% accuracy, and it just really did not work in like an actual practical setting, but it was a good proof of concept. So that's eventually when we figured out that a convolution 2D neural network is actually a lot better for images and processing images. The only downfall with that was we couldn't use grayscale with the specific one we used because it needed a certain number of color channels for it to work. So we used convolution 2D neural network, and we got up to, as you can see down here, over 10 epochs, we got it to like around 90% accuracy, and we trained it multiple times, and each time it went around 91% accuracy max. And we tried it with like 7 to 10 epochs, and around there is when it hit its peak each time. And we overfitting was a real concern. When we used the first version of it, overfitting was a massive issue because it would say it was 100% accurate on our training data, but it was not at all accurate with our testing data. So to fix that, Keras actually has a and TensorFlow have a like while you're for the model dot fit generator method there, you can add a parameter, that's the word, a parameter to check, like, to validate the the training as you're going through. So you're basically feeding in the testing data each epoch, and as you can see down here, the val accuracy, that is it's doing the testing data each epoch, and that makes sure that it doesn't overfit, and it can correct if it is overfitting. Oh,
so as much as this is a really great idea for COVID, we did come across a couple of shortcomings, one of which being the ability to obtain a larger data set. we mostly got things off of Google, which was great, but it didn't necessarily have all the angles. And as far as the camera went, we obviously couldn't get together or get more people in a room to test the camera with. So that's something we could have fixed. The other two shortcomings listed here had mainly to do with time. So the first one, not being able to detect improperly worn masks and face shields, just wasn't something we were necessarily able to explore within the time frame that we had, especially because of the small amount of data sets for improperly worn masks, and face shields being see-through made the camera a bit of a challenge, and obviously accuracy would go up if we had more time to perfect the code itself. And then for the conclusion, this just goes over the fact that this is a applicable use of AI. It is very real and very much out there already, as we have talked about. This is a demonstration of the AI concepts for us, such as overfitting, the large data sets, neural networks, stuff like that, and it is a proof of concept. We did explore what we set out to do.
I was muted. Alright, so I did the help with the data collection, did a lot of the so I worked with the ImageDataGenerator class, and worked with the AI model itself and trying to figure out what worked best and what worked best with which data sets, as well as helping bug fixes and overseeing it. Greg?
I also did data collection, and I made both programs to use the webcam and just pull stuff from the webcam's output and shove it in our program. Initially, we wanted to do it by saving the files and then rereading them, but I found a way that was a little better than that. And I made it so that, I made it auto crop all the faces, and at one point auto edge out every single face. With a program that allowed it to just pick the optimal intensity of the outlining.
And then I did things such as bookkeeping, which had to do with stuff like documents we had to turn in throughout the semester. That included the bibliography at the very end, which we'll see in a later slide. Obviously helped out in the data collection at the beginning and was following along with the code updates to see if I had anything I could add to it.
I'll say Greg was basically our like resident OpenCV expert. He did pretty much everything with it. And here's all our references and the appendix with the link, our data set that we created, and our source code.